Hello, everyone. I'm Sanjana from Ignite Coaching Center, and welcome to today's session. In our previous session, we discussed the NATA 2025 updates, and today we are diving deeper into part B of the NATA exam. Specifically, we will be covering the different topics and their rough weightage, along with one example question for each topic to give you a clear idea. To kick things off, let's quickly go over the topics in Part B of NATA. This section is crucial for assessing various reasoning skills that architects need in real world practice. First one is diagrammatic reasoning. This section tests logical reasoning using diagrams and scenarios, a key skill for architects as they work with visual representations of design. Second one is numerical reasoning. Here, you will solve problems that assess logical reasoning using numbers, essential for structural and material calculations in architecture. Third one is verbal reasoning. This area evaluates your ability to analyze and interpret verbal logic, a crucial skill when dealing with specifications, design briefs, and contracts. Fourth one is inductive reasoning. It tests your ability to identify patterns and analyze data, helping in understanding design sequences and trends. Fifth one is situational judgment. This section assesses your problem-solving abilities when faced with real-life architectural scenarios, such as budget constraints or ethical decisions. Sixth one is logical reasoning. It evaluates your ability to recognize patterns, sequences, or relationships between shapes and imageries, which is fundamental for architectural design. And the seventh one is abstract reasoning. It tests your ability to apply general knowledge to new, unfamiliar situations, a skill that is crucial for innovative thinking in architecture. Now let's take a look at the rough weightage of the questions you can expect to encounter on the NATA exam. This will help you allocate time and focus your preparation accordingly. First one, you can see numerical and logical reasoning has a weightage of about 20 to 25%. Next, you have aptitude and analytical reasoning with a weightage of about 25 to 30%. Next, you have history of architecture and terminologies with a weightage of about 15 to 20%. And the next one, climatology and environment with a weightage of about 10 to 15%. And the last one, general knowledge and current affairs in architecture with a weightage of about 10 to 15%. As you can see, aptitude and analytical reasoning is the most heavily weighted, so be sure to spend enough time honing those skills. Now let's move on to an example of each of these. First one, we have the diagrammatic reasoning. This section is included because spatial understanding is critical for architects, especially when visualizing 3D structures from 2D drawings or interpreting plans. Here we can see the question, which asks for a figure which is different from the rest, and we can quite obviously make out that it is option C. Diagrammatic reasoning in NATA assesses an architect's ability to visualize 3D structures, interpret design plans, and recognize geometrical patterns. It also evaluates problem-solving skills essential for construction detailing, modular design, and logical transformations. Now moving on to the numerical reasoning, which evaluates how well you understand numbers in the context of design, such as geometry, area calculations, and load distribution. The example question is, a circular garden has a diameter of 14 meters. What is its area? Option A, 154 meters square. Option B, 308 meters square. Option C, 616 meters square. Option D, 88 meters square. The solution, we use the formula for the area of a circle, which is A is equal to pi r square, where the radius is half of the diameter. So r is equal to 7 meters. Using pi as 22 by 7, the area is 154 meters square. Numerical reasoning in NATA is crucial for architects to apply ratios, proportions, and measurements in design and planning. It also strengthens problem-solving skills needed for structural integrity, 3D modeling, cost estimation, and spatial optimization. Moving on to verbal reasoning. This section assesses your ability to think critically and analyze verbal information, skills you will use when interpreting design briefs and specifications. Now let's take a look at the example question. It is a statement and conclusion based question. The statement goes, all architects are designers. Some designers are not artists. Which conclusion logically follows? Option A, some architects are definitely artists. Option B, some designers may be architects. Option C, all designers are architects. Option D, no architects are artists. The answer is option B, some designers may be architects, and this follows logically based on the given statement. Now moving on to inductive reasoning. This tests your ability to identify patterns and sequences. This is critical for conceptualizing, building layouts, and modular designs. The example question goes, which of the following shapes logically follows in the sequence? Given sequence, a black square, a purple square, black square, and purple square. And the next one is the question. The solution, the pattern alternates between a filled square and a purple square. Since the last shape is a purple square, the next one should be a black square. Now let's take a look at the example of a situational judgment. In this section, you will need to demonstrate your decision-making ability when faced with real-world scenarios. The example question, you are designing a house for a client with a budget constraint. The client insists on using an expensive material that will exceed their budget. What is the best response? Option A, proceed with the expensive material as per the client's request. Option B, inform the client about the budget concern and suggest alternative materials. Option C, reduce the design complexity to accommodate the expensive material. Option D, ignore the client's request and proceed with a cost-effective material. So the answer, the best response is option B. Inform the client's concern and suggest alternative materials, as this balances ethical responsibility and budget management. Logical reasoning tests your ability to recognize sequences or relationships between numbers, shapes, or images, which is essential for understanding geometrical patterns and design structures. The example question, identify the missing number in the sequence 2, 6, 12, 20, 42. Option A, 30. Option B, 28. Option C, 32. Option D, 36. The solution, the pattern follows the formula n square plus n. So 1 square plus 1 is equal to 2. 2 square plus 2 is equal to 6. 3 square plus 3 is equal to 12. 4 square plus 4 is equal to 20. 5 square plus 5 is equal to 30. So the correct answer is option A, 30. Lastly, abstract reasoning. Abstract reasoning assesses your ability to think conceptually and logically about unfamiliar situations. This is a key skill in innovative architectural design. Example question: we have to complete the sequence of figure based on the given pattern. The answer: there are four rules consistent in the sequence. First, the number of dots appearing in the center is decreasing by 1, as is the number of sides appearing on the black shape. The triangle is being flipped sideways and then back again. And finally, the square in the corner remains the same. So the correct answer is option B. So, to summarize, we have covered the key topics in part B of NATA. We have also walked through examples of diagrammatic reasoning, numerical reasoning, verbal reasoning, inductive reasoning, situational judgment, logical reasoning, and abstract reasoning. These skills are essential not just for the exam, but for real world architecture. As you prepare for NATA, make sure to practice these reasoning skills regularly to sharpen your thinking. I hope this session helps you understand the areas you need to focus on. Good luck with your preparations and thank you.